You've already been introduced to exponential functions, and when we did that, we talked about how in this case the 40 would represent the y-intercept or the original amount, and the number that is in the parentheses with the exponent is the growth or decay factor. So remember that anytime your number in here, your growth factor, is larger than 1, you have exponential growth, so you're going to follow a path like that. And anytime that number is less than 1, you have exponential decay or decreasing. The next thing to know about this is very often you're going to be talking about exponential growth and decay as a percent. Well, anytime you have a percent in this case, you're going to go ahead and rewrite it as a decimal. So 40% is a 0.40 because, as you remember, yay, middle school, you move the decimal 2 places to the left. So 8% is 0.08 because you have to move it 1 and then another spot, which means you put in a 0 there. And 80% would be 0.8. Please be aware that it's going to be very easy to mix up the decimal equivalent of 8% and 80% because it has that little pesky 0. So we're going to take a look at how that growth or decay rate shows up in the equation. And I have a form up here that you may or may not need to use because this might go very intuitively for you. For example, if I had a 34% growth rate, what I'll end up doing when I make my equation is I'll plug that 34% in as a decimal and combine it with a 1. So 34% growth rate is 1.34. I know it's growth because that number is bigger than 1. And what I could do if I wanted to use this is always go 1 plus the growth rate. So in this case, it's a 1 plus a decimal of 0.34. That's a 1.34. So if I had a 4% growth rate, I would know that's a 0.04 as a decimal, and I could jump straight to 1.04. Or if I didn't like jumping straight to that, I could say what I really did is 1 plus my growth rate. 1 plus my growth rate is that. But now I look at this and I know I have my y-intercept, and I also have exponential growth of 4%. The same idea happens with the decay rate. If I have a 30% decay rate, I know the number that I eventually have inside here has to be less than 1 to represent decay. And 30% as a decimal is 0.30. So I always base it off of 1. 1 minus 0.3 gives me my decay rate. So a lot of times people will jump right from here to here, but this is what's going on inside their head. If I had a 6% decay rate, the decimal is 0.06. I know I have to be less than 1 because we have decay. So 1 minus that leaves me the 0.94, and my eyeballs see, oh yeah, that's a decay. But that's not a decay of 94%. That's a decay rate of 6%. Here we have an example of how exponential growth and decay would show up in real-world situations. Apartment rents are increasing at 7% per year, and we're currently paying $825 in rent. Anytime something is growing or decreasing by a percent, you have exponential growth or decay. So I know my original amount, that's my y-intercept. This is growth, and I know that's a 0.07. So I combine that with 1 plus 0.07, and now I have my exponential growth and decay. Original rent growing by 7% per year. And from there, I could figure out a projected rent any year into the future. So if I wanted to know the rent 10 years from now, if this pattern held true, then I would just say 10 years, I plug in a 10. And remember that you have to be very careful with beautiful Princess PEMDAS here. She is going to request that you do the exponent before you do the multiplying. So 1.07 raised to the 10th power. Then we multiply by the 825. And 10 years from now, my rent is going to be at about $1,623 instead of the nice $825 I'm paying right now. One final example of these, you have money in a retirement account, you have $940,000, and you're taking it out at 12% per year so you can spend it and have fun. So if money is coming out of the account at 12%, I know I have decay, so I have to do 1 minus the decay rate, and that's going to be a 0.88. So now I have to go ahead and make my equation. My original amount, my decay rate, that's not an 88% decay rate, that's a 12% decay rate per year. So now if I want to figure out how much is in my account in the future, if I was interested in 15 years from now, I plug in a time or a year 15. Beautiful Princess PEMDAS says, go ahead and work this out first, then do your multiplying. And 15 years from now, my account that used to be at 940,000 is at about 138,000. I definitely experienced exponential decay or decline.